Hello, my name is Mariam Abdullah, and I'm here to talk about how machine learning can be used in the implementation of beyond 5G networks here in the UAE. The development of 5G networks has been one of the hottest talked about topics in the scientific and telecommunication communities over the past few years. This new generation of networks promises to deliver higher data rates, lower latency, increased capacity, and an overall more uniform experience to users all over. And these capabilities aren't just going to improve daily users' lives while they use the internet, but they also provide massive potential for connecting new industries such as healthcare, autonomous driving, IoT devices, and connected homes. And just to give an example of how much these new applications would increase the demands on our current networks, IoT devices alone are expected to increase the capacity on the current networks by almost 100 times. So it's very important for us to develop our networks in order to be able to handle such future applications. The good news is that UAE has been doing a great job in the deployment and development of 5G networks. In fact, UAE has been ranked number 1 amongst all Arab countries and 4th worldwide in the deployment of 5G networks. So, we've talked a lot about why we should improve our networks, but how can machine learning be used to do this? Well, the key here is resource allocation and optimization. Networks typically have limited amounts of resources. The most typically talked about one is bandwidth. The key to optimizing our network is to optimize these resources. Let's take an example of a very simple network consisting of 2 cell towers, and each cell tower can handle a maximum of 2 customers. Let's pretend that cell tower 1 is currently processing 2 customers, so it does not have any bandwidth left. And a new customer comes in requesting for a task to be done. So cell tower 1 now has a decision to make. Should it put the new customer on hold until one of the customers leaves? Or should it ask its neighboring cell tower to offload the task there and have the task processed there? This is called offloading, and usually it's a bit more expensive and allows the user to experience a little bit more delay. However, it might be a better alternative than to have the customer just wait. But let's also say that one of the 2 customers are about to be done with their task within a few seconds. How can the cell tower decide whether it's better to wait or offload the task? Let's also pretend that the neighboring cell tower is also occupied with 2 customers. Obviously, in a real network, there's going to be more than just 2 cell towers. There's going to be tens, if not hundreds, of cell towers. Our original cell tower can ask the next neighboring cell tower if it has available bandwidth, but that takes extra time. So how will our cell tower know which cell tower to ask? Optimizing all these decisions is the key to allowing a better user experience and to overall increase the efficiency of the entire system. And this is where machine learning plays a major role. Getting a machine learning model here to predict the number of customers at each cell tower or traffic at each cell tower would be the key to optimizing all these decisions. If we can get a model to predict a peak in traffic or a peak in number of customers minutes or even hours before this peak even happens, the cell tower can start processing all the available options it has to see where it can offload its tasks, or what optimal decisions it can do to reduce the delay on each customer as much as possible to provide each customer with a more uniform experience. Graph convolutional networks are one of the most promising tasks to predict such traffic. With graph convolutional networks, data here is presented as a graph, where each cell tower is presented as a node in a graph or a grid. Here, not only will the model be able to learn traffic prediction based on the history of traffic on each cell tower, it will also be able to learn it from the topological structure of the network, which, as we just mentioned, is highly correlated because each cell tower's traffic doesn't only depend on its local users, but it could also be affected by the offloaded tasks it receives. The great thing about such a model is that not only can it be trained on the history of traffic patterns and the topological structure of the network, it can also be trained on external factors such as weather or day of the week. These things are quite important to consider because human behavior is highly dependent on such external factors. Think, for example, if the weather is nice, it's sunny and it's not too hot outside, more people would be outside at the beach or at parks, so cell towers near these areas would experience higher than usual traffic. So considering these things in our training would also highly improve the accuracy of our prediction model. And again, having accurate prediction of traffic would help optimize the overall system. So, to summarize everything, machine learning has great potential in it being implemented in the UAE to be able to improve our network architecture and network topology to help the UAE get prepared for the development of the next generation of communication networks, and to be able to help UAE stay ahead of the curve, so when the next generation is developed and the deployment of it is starting, the UAE can achieve first place globally in its deployment and implementation.